Good morning, ladies and gentlemen. Welcome to this AWS Discovery Day. Welcome to another webinar. This webinar is about security. So if you came to find out some information about how can you secure your cloud workload, you definitely came to the right place. This webinar is going to take about an hour and a half. Should you have any questions, please, there's the chat functionality in this platform, so you can send me all of your questions. And at the end of this webinar, I'll promise I'll find a couple of minutes to answer your questions. So if you have any questions, please send them. And at the end of this webinar, we will address them. As we said, we only have 1.5 hours, and since security is it's a major topic in AWS, you know, we could be talking for days and for weeks about security. Let's not waste any time, and let's jump right into it. Maybe a little bit about me. My name is Thomas. I've been around AWS for almost a decade. I've worked with a variety of various clients, small projects, big projects, you name it. Don't worry, I'm not here to brag about myself, but should anybody wish to stay in touch after this webinar, even after this webinar, if you have any questions, I'm a big AWS geek, so the QR code is for my LinkedIn profile, so feel free to find me on LinkedIn, and I'll be very happy to chat with you about anything AWS related. Big passion for me, so I'll be super happy to discuss that. Link to my LinkedIn profile should anybody wishes to stay in touch with me even after this webinar is over. So in this webinar, we're going to talk about security. We're going to talk about AWS. We definitely have to start our discussion about, you know, if you're considering moving to AWS, why should you consider this move in the first place? What we can see in the slide in front of us is a couple of benefits that are recognized as the most important ones that cloud can offer to us. With cloud, we've got infinite elasticity option. So usually cloud is the place that can increase our speed, increase our agility, increase our digital transformation. So cloud is this platform where, you know, truly sky is the limit. So whatever constraints we had in a traditional on-prem environment, maybe, you know, all technology, all hardware, or equipment, all of these constraints are gone when we move to the cloud. The world is our oyster now. We can take use of all of the benefits that cloud offers. We can start offering our products and services to millions of customers around the world with you know, a couple of clicks of the button. So we've got cloud is amazing place with incredible potential that can help us to move our business further. AWS is a truly global cloud environment. We've got we've got AWS owns data centers all around the world. We've got plenty of AWS regions, so collections like clusters of data centers. Furthermore, we've got over 450 plus AWS points of presence, so locations where we can use to cache our content or use these locations for rapid delivery of our content. So no matter where the customers are located, we can serve them immediately. Another important benefit of cloud is pay-as-you-go model. You might be used to this like traditional model in on-premise environment. All right, I want to create an application. I need some analysis. I need to figure out how much stuff do I need, and then I can purchase it. Maybe a couple of months later, I've got my equipment, and now I can start figuring out how to do this application. With cloud, this is no longer the case anymore. Do I need 100 servers? One click, I've got 100 servers. I no longer need these 100 servers, another click, and I will stop paying for them. And I've only paid for these 100 servers for the time duration that I've used them. So I've got access to all of these resources, and I can only billed. I will only pay for resources that are actually used. All right, so enough promotion of this cloud platform. Why don't we actually take a look at why we all here today, which is security. So let's dive in. into the security. How can we secure our cloud environment? How can we make sure that everything we do in AWS is well secured? When it comes to AWS account, so to start with, we will first create an AWS account. So very easy to do. Anybody can go online. Essentially, you just need your email address and a credit card, put it in, and you've got your AWS account. So you've got your own space in AWS Cloud where you can provision your resources. When you create AWS account, you will always get this like 12-digit number, which is a unique identifier of your account. Awesome. So you go online, you put your email address, you put your credit card info. Now you've got your AWS account. What are you going to do? How are you going to provision resources? Who's responsible for what? If you ever find yourself wondering, like, okay, so I've got all of these 200 plus products that I can provision in AWS. Am I responsible for this? Am I responsible for that? Is AWS going to do this for me? Is AWS expect me to do that? If you have similar questions, you can find answers to all of your questions in AWS Shared Responsibility Model. So AWS Shared Responsibility Model is a framework that's published by AWS that clearly divides the responsibility between the cloud provider, which is AWS, and us, the customers, and us, the AWS customers. This is very important because we always need to know what's expected of us and what we can expect AWS to do. This framework actually varies because we've got over 200 different services. Some services offers us more flexibility, more control, we've got more options, but also at the same time, we've got more responsibility. On the other hand, some responsibilities are more managed by AWS. AWS takes on more of these administration duties, and also AWS will then be responsible for these part of services. So depending on which particular AWS service we're using, we should always check the shared responsibility model and find out for that particular service what's expected of us and what we can expect from AWS. What we can see in the slide is this general model. Essentially, in general, AWS, which is the lower section down here, will always be responsible for security of the cloud. So making sure that everything, the whole cloud platform is secure, data centers are secure, the whole environment is secure. And us, AWS customers, we will always be responsible for security in the cloud. So whatever data we put in, whatever services we've provisioned, whatever configuration we put for these services, whatever we do inside of the cloud, we will always be responsible for that. So that's the general AWS security of the cloud. Are we AWS customers security in the cloud? Now, you might be curious, okay, so there's definitely no lot when it comes to security. What are some of the security principles that we can see in AWS? On this slide, we've highlighted 7 most important security principles that we always need to consider while operating in AWS environment. I'm not saying that these 7 security principles are the only security principles, and if you do that, everything else it's fine. No, these are the most important ones. The first one, very important, it's apply principle of least privilege. If you're from security background, I'm sure we are very familiar with this concept. Essentially, we should only authorize people and application for that level of access that is required for their job duty. I know sometimes it's a little bit tough, we're busy, we're in a meeting, someone really needs quickly something. And so it might be tempting to, not really try to tailor the policy according to the use case, but, give like a broad level of permission and just say, okay, I'll fix it later. Never, ever a good idea. Always people and application services should be only granted that level of access that's necessary for whatever activities they will be performing in AWS. Also, in AWS, we've got an option to avoid these long-term credentials. In AWS, we've got a concept of IAM roles, which can give us temporary credentials that are automatically rotated, that only have validity, whatever we set, a couple of minutes, typically. As you can imagine, definitely more secure solution. I can have these credentials automatically rotated, only valid for a couple of minutes. If something bad happens, only valid a couple of minutes, not that major issues as if my long-term credentials get leaked. So always consider using these short-term credentials versus the long-term ones. So that was the first principle. The second one, enable traceability. Obviously very important. We need to know exactly what is happening in our AWS environment any given time. So everything that's happening inside our AWS environment should be monitored and should be logged. There's one great service that can help us with that. It's called CloudTrail. If you're not familiar with the CloudTrail, there's a service that records every single API call that arrives to AWS endpoint. So whatever people are doing, applications are doing, whatever is happening, in the end, it's just an API call, and all of these API call gets recorded. So definitely encourage you to enable traceability and use some of the services such as CloudTrail that have been designed for this occasion. The next principle is to apply security at all layers. Very important principle. I sometimes see customers, utilizing a security service, a single product, single solution, single service, and thinking that, okay, I've got this, one big firewall sitting here. Now it's fine, everything else it's fine. It's never a good idea. There can always be, some misconfigurations, maybe unintentional misconfigurations, or maybe that could be even intentional. Could be some sort of like attack happening on that service. If that potential attacker is able to get through, now the attacker is able to see everything, to get everywhere. So it's never ever a good idea to depend on a single product, single service, single solution. Always recommended approach is to have multiple layer of defenses. In AWS, we've got a whole variety of security services. Should we use service 1? Should we use service 2, 3? Of course we should. We should use all of them. So the recommended approach would be to implement several layers of defenses. Now, should there be some misconfiguration? Should there be like a real attack? Doesn't really matter. We've got another layers that can protect us, that can stop that potential attacker. So we're not now, depending on that one particular solution. So definitely increment multiple layers of defenses and use multiple different various AWS or third-party services. The next approach is automation. Automation is essential. In AWS, we can use purpose-built tools that can automate many tasks that we usually spend so much time on. We're all, we're only people, right? We only have, we can only click, with our mouse certain speed. People make mistakes. Everybody makes mistake. It's never a good idea to depend our security on, somebody working late at night that, follows the detailed manual that we gave that person, from top to bottom. People make mistakes. Mistakes happen very commonly. The best way how to avoid mistakes is to use automation. In AWS, we can actually automate all of our security. We can write all of our security in the code, and then we can have all of our security product solutions implemented automatically using the automation services. Very, very essential. I really like this concept. What we see in a DevOps world nowadays. Now, we start speaking about not only a DevOps world, but also of the DevSecOps world. Essentially meaning that the security is implemented. Security is not only like an afterthought, somebody build an application, now gives it to the security expert, usually with the message that, that thing should have been deployed yesterday. So, quickly approve it. But security should be implemented in every step of the way. This is not only true for the DevOps practices, this should also be true for architecting any other application in AWS. So whatever solution I'm architecting, ideally use automation for any kind of deployment, whether it's application deployment, infrastructure deployment, whatever resources I want to provision in AWS. And while I'm using these automation tools for provisioning my resources, I should also implement the security as part of that particular template, particular solution that's being provisioned. So not only applications can be provisioned using security, but also the applications can be provisioned using automation, but also the security should be provisioned using the automation as well. Now, the next tool is about data protection. In AWS, we can use two kinds of protection. We can protect data in transit, and we can protect data in rest. Should we protect data in transit? Absolutely. Should we protect data in rest? Absolutely as well. So both kind of encryption is available in AWS, and I would definitely encourage everyone to use both encryption, whether the data is moving somewhere or the data is being stored at our final destination. When it comes to encryption in transit, all AWS endpoints utilize HTTPS. We can use VPN, TLS connection. So we can use certificates for encryption. So we can use all familiar tool. It's all in there. When it comes to encryption at rest, essentially all AWS services that store data also offers us encryption options. Usually we have plenty of options. We can either leave all the encryptions to AWS, or we can manage our own encryption using dedicated encryption services. So whatever our encryption environment, our encryption needs are, do we leave all of it to AWS, or do we want to have the ability to manage the encryption keys ourselves, create the policies ourselves, or simply do we want to do everything ourselves, encrypt everything in cloud and send it already encrypted to AWS environment? Whatever encryption options we want, we can achieve them in AWS. The next security principle is a very important one. It's to prepare for security events. Even though we will all try to architect a solution, so we will minimize any potential of having a security event, we're never ever able to truly fully eliminate the situation. So security events might happen, might occasionally happen. Hopefully the security events will not be significant. So we've already implemented all the previous practices like encryption, like using multiple layers of protections, etc. But every now and then, a certain security event should happen. If a security event should happen, we need to know exactly what we need to do. Probably the worst thing that can happen to us, we figure out there's a security event, and now we're trying to find out, okay, what do I do? Okay, we might have someone who knows what to do. Where's that person? The person is on holiday, or maybe the person is no longer working in our company. Okay, what do I do instead? So we definitely don't want to be we definitely don't want to find ourselves in this situation. So the preparation is the key. We should have plans. If certain things happen, we know exactly step by step what action do we have to implement to mitigate that situation. The idea is usually to try to isolate the problem as quickly as possible, restore operations as quickly as possible, and then after we've got a problem isolated, maybe there's a server with some spyware on it, then we can take the server into the safe environment, and then we can run all of our analytics and figure out what happened, how is it possible, what security configuration do we have to implement, or maybe what misconfiguration we had in the first place, so what misconfigurations we had to fix. Okay, and the last security principle that I've got for us is to minimize attack surface. This security principle is especially true if we have internet-enabled infrastructure, if you're offering our products and services, using the public internet. As we know, in the public internet, we've got plenty of threats. We've all heard of these massive, DDoS attacks affecting all the, big companies in the world. So definitely we need to prepare our infrastructure to withstand these kind of attacks. What is very nice, if we're using AWS security services, we can do a very effective and efficient DDoS attack mitigation. Essentially, there are security services that have been specifically created to protect our infrastructure. We've got a different kind of firewalls that are operating on different layer in the OSI layer stack, so we can protect our resources against infrastructure layer attacks, so layer 3, 4 on the OSI model, application layer attack on a layer 7. So we do have AWS services that can help us to mitigate these attacks and protect our infrastructure against them. Also, at the same time, even if we put all of these protection services in place, it is always possible, and it's always very likely that maybe some of the attack might still get through, even if all of these security services are able to filter out, say, 99% of malicious traffic. Still, some traffic might get through, which should not really be an issue for us, because we can architect our services in AWS with flexibility in mind. So our protection services will try to block as much of this attack as possible, and at the same time, our infrastructure can temporarily scale up to accommodate the leftover of these attacks. So really, the threats out there in the internet that are out there in the internet should not really be an issue for us if we architect our solutions appropriately. Now, what is your security posture? What is our security posture in AWS? Again, we do have a couple security areas that we have to discuss, that we have to address in order to improve our security posture. So the first area is about authentication. So when you're talking about authentication, we're asking about who's making requests to AWS. We need to uniquely identify the person, the application, the service, whoever it might be that is making a request to AWS. When it comes to authentication, all of the authentications issues and authentications worried can be accessed by AWS IAM, which stands for Identity and Access Management. So AWS IAM is the service, is a web service that can help us to implement authentication, authorization, and user management for our AWS resources. So essentially, AWS IAM is the service that sits at every single AWS API endpoint. So any possible place we might want to use to get to AWS, every possible place there is the IAM service sitting there. So any request that goes into the AWS is first verified by IAM, and IAM will uniquely identify the identity of the counterparty, so the person, application, service, product, SDK, whatever is calling us. So we exactly know whoever's making every single request in AWS. Typically, anonymous requests are not supported. So you've got authentication covered by AWS IAM. If we have authentication covered, you might be curious about, all right, how do I implement authorization? So I now know, who's making requests. I now know the identity of the caller, but based on the identity of the caller, I need to assign that caller some sort of permissions. When it comes to authorization, again, authorization will be handled by the same service, which is AWS IAM. How does it work in AWS IAM? With AWS IAM, we can create policies. So policy is essentially a document that will grant somebody or something whatever permissions we desired. When we're working with AWS IAM, the default posture is nobody has any permission. So by default, nobody can do anything in AWS. After we create some sort of identity, we create, let's say, IAM user or IAM role. Now we have an identity that can call AWS. Again, by default, that identity has zero permission. So in AWS, we will always start with zero permission. By default, nobody can do anything. If we want to authorize somebody or something to allow them to perform some actions in AWS, we have to explicitly grant them permission for that particular action. For instance, if we want to allow somebody to create an S3 bucket, S3 is an object storage service that will allow us to store all of our objects that we have. So if we want to allow somebody for this particular action, we have to create an IAM policy giving that identity rights for create bucket operation. So we have to explicitly create policies to allow people or to allow applications to allow anybody do any kind of activities in AWS. So we have to explicitly allow them some action. As you can see, we can also explicitly deny some actions. Essentially, the explicit deny is very helpful because in AWS, deny always wins. So if we have multiple policies, these multiple policies allow some actions and deny some actions. You might be curious about, how the evaluation works, like who wins in the end. In the end, deny always wins. So as soon as we have a single deny in any of the policies attached to that identity, the deny will always win. So that identity will not be able to perform that action, regardless, on 50 other places that identity is allowed that action. So we've got authentication and we've got authorization covered. The next part, it's about monitoring. Obviously, we need to be aware of everything that's happening in our environment. Should there be a security incident, we need to be aware of that. We need to monitor that situation. When it comes to monitoring in AWS, there is one web service that we will use for all kinds of monitoring, which is called Amazon CloudWatch. So Amazon CloudWatch is a web service that we can use to monitor all AWS Cloud resources. Essentially anything that's running in our AWS environment. If we have some web servers, we're interested in, let's say, CPU utilization, network throughput. We have some databases, maybe we have some networks created. Any service, any product that's running in our AWS account, if we're interested in the performance of that particular service, all of our monitoring questions can be answered by Amazon CloudWatch. In addition of Amazon CloudWatch being a monitoring service, we can also use the alarm functionality in Amazon CloudWatch, meaning that we're monitoring some specific metric, and if that metric breaches certain threshold, operation that we configure can take place. Maybe we can send somebody email, maybe we can send somebody a text message, maybe we can automatically initiate some action. So all of it, it's possible to configure using Amazon CloudWatch. Amazon CloudWatch can also help us to react for events that are happening inside our AWS account. Imagine an event being a change and a significant change in AWS resources. That change might be like maybe a new web server is created, maybe a server is being terminated, maybe a configuration of server is being changed, maybe it's something, maybe a new database is being created. All of these produce this near real-time stream of system events that describe that change that happen in AWS. If we want to implement some automation, maybe we want to automatically, run some checks, run some verification, or maybe you just want to notify somebody that situation happened. We can also configure it using Amazon CloudWatch. So monitoring service with plenty different additional benefits. All right, so authentication, authorization, monitoring, that's all covered. Now, how do I audit? How do I find out, who did what in our AWS environment. When it comes to auditing of everything that happened inside our AWS environment, we've already mentioned the name of the service. It's called AWS Cloud Trail. So AWS Cloud Trail is a web service that records API calls that are made in our AWS accounts. So it doesn't really matter which channel are we using. Maybe somebody is logged in using the web browser in our AWS account. Maybe somebody is using a CLI. Maybe we have some applications that are using SDK. All of it, in the end, all of these actions, regardless of the channel, in the end will be transformed as API calls that will be sent to AWS API endpoints. As we know, at all AWS API endpoints, we have IAM, Identity and Access Management. So this is the first service that will find out who made the call and if that entity is authorized to make that call. Obviously, if the entity is not authorized to make that call will be disregarded. Second service that's sitting there right next to the IAM, it's AWS Cloud Trail. So first, the call will be verified by IAM. Second, the call will be recorded by a Cloud Trail. So very easy, we can come back to the Cloud Trail history. By default, every single AWS account has Cloud Trail on. That's turned on for management event, and we have past 90-day window. So it's a rolling window. So we can find out, in past 90 days, all of the API calls that were made. This is the default configuration. So there's nothing for us to do. Obviously, if we want to store this information for longer, we want to store the information in a location that we specify. We can create something which is called a trail. Essentially, Cloud Trail can offload all of this data into the location that we specify, and now we've got all of the logs that we can potentially store indefinitely. So by default, past 90 days, but we can create a trail and store the data in our own location and manage the data on our own. Okay, so we've got a logging captured as well. How about encryption? How does it work with encryption? Is our data encrypted at rest or in transit? When it comes to encryption, we've got multiple options. If we want to handle all of the encryption ourselves, we can utilize client-side encryption. Client-side encryption essentially means that I will encrypt the data before I send the data to AWS. Perhaps if you've already invested heavily in some encryption hardware and encryption software, I want to utilize that investment. So I will encrypt all of the data in my facility, and now I'm sending the data that's already encrypted to AWS. AWS doesn't have the keys. I will be managing all of the encryption myself. It is possible. Or what we can implement is the server-side encryption. So with the server-side encryption, it means that AWS will encrypt the data on our behalf after the service has received the data. So essentially, this time we're utilizing AWS products and services for the encryption. We will focus on this server-side encryption. When it comes to server-side encryption, again, we have plenty of options. Most of the services utilize a native server-side encryption, so we can encrypt the service, we can encrypt the data, and the key will be managed by that particular service. For instance, coming back to the S3 example, we can use server-side encryption in S3, and the service itself, S3, will be responsible for managing the key. We can use the similar situation in a different services that are storing data. Now, sometimes, and this is actually what we typically do, we want to have the control over the encryption keys. We want to have the ability to create the policies that will grant somebody access to the encryption keys and will deny somebody else or something else access to the keys. So if we need to have the control over this encryption process and the encryption keys, we can use a dedicated service, which is called AWS KMS, or Key Management Service. So this is a service that will give us this ability, this control of managing the encryption keys. So we can create our own encryption keys. By the way, when we are creating our own encryption keys in KMS, we can also import the keys that we've created in our on-premise environment. So if we have some mechanism of generating the keys, generating the key materials, and we want to import it into AWS, it is very possible we can still use KMS for it. If we don't have this option, or if we do not want to generate the key material ourselves, we can also let KMS to generate the key material on our behalf. So all of the options are possible, and we still have full control over that encryption key. So we can create a key policy and specify who or which application, which services, under which conditions can use this key. What's very nice about the AWS KMS is the AWS service that's integrated with all other AWS services that are utilizing encryption. So we don't have to reinvent the wheel. We don't have to figure out, like, from our application code, how to use some like libraries, like Java libraries for encryptions, etc. Everything is already integrated, and at the end of the day, it's usually as easy as a checkbox, as clicking a checkbox. Do I want to have data encrypted? There's usually a checkbox. I click on the checkbox, and now I've got my data encrypted. I simply specify the key that I want to use for the encryption, and that's it. So usually encryption in AWS, it's a very, very simple thing to do. That's why we always encourage everyone to use encryption, have everything encrypted. It presents very little performance limitation, costing very little impact on our AWS Cloud bill. So definitely encourage and recommend it to use both encryption in transit and at rest any place that we can use it. How AWS will protect us with encryption in transit? So AWS offers HTTP endpoints, so all the communication between us, regardless wherever we are, and AWS can be done using encryption. So we can use HTTPS, TLS. We can also create our own certificates using a service called AWS Certificate Manager. So if we have web application, we've purchased a domain, example.com, and we want to utilize certificates for our domain and for the resources that will be accessible via the domains, we can generate certificates. By the way, generating certificates for AWS resources, it's free, which is very nice. We can also generate certificates for other resources. So definitely anything that's running in AWS can be fully encrypted, both in transit and at rest. Okay, now moving on from the encryption into the networking world. So how do we create networks in AWS? How can we secure and protect our networks in AWS? When it comes to creating a network in AWS, we use one service that can offers us to do exactly that, which is called Amazon Virtual Private Cloud, commonly abbreviated as Amazon VPC. Essentially, Amazon VPC is a service that will help us to create our own section in AWS Cloud, where we have full control over what can we do with it, what resources we're going to provision into it, what IP addresses or what blocks of IP addresses will we be using, how we're going to segment that network even further. Typically, we create some private parts and some public parts, how we're going to configure firewalls and other security mechanisms. So we have a full control over everything that happens inside the VPC that we've created ourselves. When you started with AWS, when you open up a brand new AWS account, there's already going to be a default VPC created for us. So essentially, AWS wants to make our life a little bit easier. We've already have a place to start with. However, what customers typically do is to delete the default VPC and create their own VPC according to their needs. So usually, customers want to use certain, blocks of IP addresses, have certain security requirements when it comes to different kind of firewalls, etc. So we can simply create our own VPC, and now we've got a full control over all of these different configurations. After we've created or some of the VPC features that we can use for the protection, when it comes to VPC, we can configure, we have when it comes to creating a VPC, we've got a control over the routing. So with a VPC, we can create a routes table, and in a route table, we can specify route. So we can specify how the traffic will be routed in between, like inside our VPC, and also leaving the VPC and going into the VPC. So we can create some part of the segments that will be directly routed to the internet gateway, which is a service that will give us internet connectivity. We can create some segments that will be fully isolated, so the communication will not be routed to any other parts of the network. So we've got a full control. We can create our own routes. Whatever network requirements we have, we can implement them. When it comes to some security features that we can implement, we can create different kind of virtual firewalls. Essentially, we've got two important ones. The first one, it's called network access control list, and the second one, it's called security group. So both of these services are kind of a virtual firewall. The first one, network access control list, this is the virtual firewall that's at the subnet level. So we have a VPC. We can divide VPCs into the subnet, and at every subnet level, we will have a network access control list. So this network access control list will specify what communication is allowed to go inside the subnet, and what communication is allowed to go outside of that subnet. So we have network access control list at the subnet level. Now, second kind of virtual firewall is a security group. So security group, it's a virtual firewall that's at the instance level. So as right here in this example, we've got a subnet. So we've got network access control list guarding that subnet. Inside of the subnet, we provision an EC2 instance. And now the EC2 instance has its own security group. So for every single resource we've provisioned inside our subnet, we've got its own little firewall that can further specify what's allowed inside that particular resource and what communication is allowed outside of that particular resource. So we've got two different kinds of virtual firewalls. So putting everything back together, we've talked about authentication, which is the step number one. Remember, we do have a service called IAM, Identity and Access Management, that sits at every AWS point of entry, every AWS API endpoint. So whatever API call AWS receives, the step number one is to figure out the identity of the caller. So it's to find out who exactly make that call. Step number two would be authorization, which is actually done using the same service, IAM. So we have IAM for both authentication and authorization. Authorization would simply specify, based on our identity, what kind of permissions, what's the access that we have. Remember, in AWS, we can grant access using IAM policies. So IAM policy is the document that specifies exactly the access that we wish to grant certain IAM identity. In this document, we can specify both allowed policies and denied policies. And in AWS, deny always wins. So even if it's something that's allowed multiple different places, as long as there's a single deny, deny will always win. And also in AWS, we will always start with 0. So after we've created an identity, the identity has 0 permissions. We have to explicitly grant permissions. In AWS, we also have a monitoring cover. For monitoring, we're using Amazon CloudWatch, which is a web service that monitors all AWS resources provisioned in that particular account. The service has some of the great features. For instance, we can configure alarms, so we can send some notifications, reminders, or we can take automated actions based on certain situations happening. And we also have the events, which we can monitor this near real-time stream of system events, so whatever is happening in our AWS environment, and we can take appropriate actions. When it comes to audit, we also got ourselves covered. So for audit, we've got AWS Cloud Trail, which records all the API calls that have arrived to AWS API endpoints. So as we know, we've got two services sitting in the endpoint, IAM and CloudTrail. So all the API calls are recorded. We've got an option, to come back into the logs and know exactly who did what. So we've got the full audit history. By default, the CloudTrail is configured for saving the past 90 days of management events. If we wish to save more data, we can create a trail, so we can offload the logs into the location that we specify, so we can store our information for whatever time period that we want. When it comes to encryption, AWS has got us covered both for encryption in transit and encryption at rest. So with encryption in transit, we can use HTTPS, we can use TLS. We have AWS certificate managers that can create certificates for all of our resources. And for encryption at rest, we've got AWS KMS, which is the service that we can use to create encryption keys, create policies, specifying who, what, which services can use the keys. When it comes to networking, there's quite a lot. The main networking services, it's called AWS VPC, which stands for Virtual Private Cloud. And it is a service that will allow us to create our own VPC, our own virtual private cloud, our own network that we can use, that we have full control over. We can specify which IP addresses we want to use, how we want to segment this network, what resources we want to provision into it, and also what kind of firewalls or virtual firewalls we have there. Remember, we've got two main virtual firewalls in AWS. We've got network access control list. So we've got the firewall that's sitting at the subnet level. That's that smaller segment of our network that guards the boundaries, so that checks all the traffic that's coming in and coming out. And we also have a security group, which is a virtual firewall at the instance level. So every resource that we provision inside the subnet, I will have its own security group, will have its own virtual firewall that will again guard that particular resource. So that's a little bit about security of AWS. We've talked a little bit about security in AWS. As you can probably say, the security is it's a major topic. We could spend hours, we could spend days, we could spend weeks talking about it. But don't worry, if you find yourself, needing more information, wanting to find out more about what AWS has to offer when it comes to security, there are plenty of very helpful resources. First one, if you want to expand your knowledge with self-paced digital courses, there is the one that's offered, which is actually free. You can access it on AWS Skill Builder portal. So AWS Skill Builder, so skillbuilder.aws. That's official AWS training portal. On this portal, you can find over 600 free courses. So if you want to train about any service, any product, anything that AWS has to offer, go on AWS Skill Builder. free AWS training portal, and you can find plenty of courses for it. Their courses offered in different languages, so you can find plenty of useful information in there. If you want more of a guided training by a real instructor, such as myself, there are also plenty of classroom trainings that can be taken both in live and also virtual. Very interesting one. It's called Security Engineering on AWS. It's a 3-day course in which we will go into more details in all the AWS security services. And we will discuss, in a great, and we will discuss all the security aspects of AWS. So, should anybody wishes to continue their security education further, definitely it's something I can personally recommend. 3-day course, security engineering on AWS. There's also the AWS Security Essential, which is a quick 1-day course covering the basic aspects of security. So you also have the options there. And lastly, there's the ramp-up guide, security. I know that there can be a lot of things, a lot of courses, a lot of webinars, a lot of blog posts. There's a lot of information everywhere. So if you want to have this information structured and kind of like recommended learning path, how to take course A, then this one, go ahead and check out the ramp up security guide. These ramp ups guide are created by AWS, not only for security, but for other areas in AWS Cloud. And it's very nice to have this kind of like this learning path, this structured approach, how we can tackle some topics. So definitely, I definitely encourage you to check that one out as well. All right, so ladies and gentlemen, that's all you're going to hear from me about the security today. As I said, security is a big topic. So definitely, don't consider yourself a security AWS experts just yet. There's much more to learn, much more to talk about when it comes to security in AWS. That's why the previous slide. So hopefully some of these resources that we've suggested could be helpful for you. You could get some additional useful information. As promised, I wanted to give you some time at the end for your questions. So if you have any questions, if you can please send your questions. We still have a couple minutes, and we can discuss, whatever question, whatever might interest you. So if you have anything, now it's the time for you to send your questions. We still have a couple minutes. So we can discuss it. All right, so I see one question, or actually, I saw several questions when it comes to AWS compliance in various geographical areas. So if you're interested about the cloud compliance in any country, Canada, US, Europe, Australia, Asia, any place that's relevant for your business, there are different sources of information. The first one, the first page, the first place that I would recommend you to check out would be AWS compliance website. So let me actually show you that. So we have the AWS compliance portal, and on the AWS compliance portal, we can find all the information when it comes to compliance and AWS. Remember, we've already talked about a shared responsibility model. We have some trainings, we have some videos, etc. So we can find all of this information. If you're interested for something specific, under the compliance overview, just go to the compliance website, and now we can find the AWS compliance in various geographical area. So as you can see right now, we've got some general compliance, PCI compliance, SOC, various different standards. I know there was a question about Canada. For instance, we've got compliance for Canadian Center for Cybersecurity and plenty other information. So there's another one, Canada's federal private sector privacy legislation. So whatever compliance standard you're interested, definitely check out this AWS compliance program, and you can find all the information in there. Another source of information, and this is only available if you have your own AWS account, is a service called AWS Artifact. And AWS Artifact will aggregate all of this information so it's accessible from within your AWS console. So if you have if you have an AWS account, you can access AWS Artifact, and in AWS Artifact, you will find all the information about AWS compliance. If you have perhaps some private agreements with AWS, you will also find this information there. So either the official compliance portal or AWS Artifact from within your own AWS account. All right, so I don't see any other questions coming up. So, ladies and gentlemen, if you do have some other question, I shared with you my LinkedIn profile. So if you have something else that you wish to discuss, find me on LinkedIn, send me your question. I'm not saying I know everything, but I know a lot of people at AWS. So even if I don't know your question, to answer your question personally, I will make sure that I will get someone that will answer it. So that's it from me, ladies and gentlemen. Thank you so much for your time today. I'm hoping you've learned a little bit more about security in AWS. I'm hoping that I've also provided you with some inspiration of when to how to further continue your security education. So thank you so much. That's it for me. I'm hoping that you've enjoyed it. Have a fantastic day. Have a great cloud journey, and I'm hoping to see you soon at some point. So thank you so much, and goodbye.